So starting with problem number 5. Number 5 says the perimeter of a square is 72 inches. What is the length of the diagonal of the square? Use special right triangle rules. Answer must be in radical form. All right, so I'm going to start off by drawing a square. And I know that all 4 angles inside of a square are going to be right angles, so these are all 90s. And because it's a square, I know that all 4 sides are going to be congruent. It tells me that the perimeter of the square is 72 inches. How do you find the perimeter for a square? You add all the sides together. How many sides are there to add together? 4 sides, and they're all the same size, right? So how would I find the size of just one side? Yes. 72 inches divided by 4. What is 72 divided by 4? 18. So each of these sides is 18 inches. We want to find the length of the diagonal. So a diagonal is going to go from corner to corner, opposite corners. And when I do that, it creates this right triangle right here that is one of our special right triangles. I have 2 sides that are congruent. There's a 90-degree angle, and these 2 90-degree angles got cut in half. What's half of a 90-degree angle? 45. So that means this yellow triangle right here is a 45, 45, 90 triangle. We had one formula for a 45, 45, 90 triangle, and that was hypotenuse equals leg times radical 2. So the hypotenuse is that diagonal equals, I don't have a short leg here and a long leg because both of my legs are the same size. How big are both legs? 18. So I would have 18 times radical 2. So the diagonal is 18 radical 2 inches. It said that my answer had to be in radical form, so I am not going to take that and put it into my calculator. I'm going to leave it just like that. What else would you guys like to see? Yes. Number 3? Absolutely, we can do number 3. Number 3 says a right triangle has a leg with a length of 12 centimeters and a hypotenuse with a length of 22 centimeters. Draw a picture and find the length of the missing side. So I'm going to draw a picture first. We know that this is a right triangle because it said so right here. So in the corner right here is my right angle. One of the legs has a length of 12 centimeters. So I just pick out one of the sides that's not the hypotenuse and call it 12 centimeters. I'm going to put that one down here. I could have easily picked the other leg, though. There's no reason why I had to pick this one. And then the hypotenuse is 22 centimeters. The hypotenuse is always opposite the right angle. So opposite my right angle, we have 22 centimeters. We want to find the length of this missing side, so I'm going to call this X. Then find the perimeter of the triangle, round to the nearest thousandth. So What can I use to find the missing side? What'd you say? I can't use SOHCAHTOA on this one because I don't have, I could use SOHCAHTOA to find an angle, and then I could maybe use that angle to find the other side. I mean, you could do it with SOHCAHTOA. It's going to take you several steps. We could use Pythagorean theorem to directly find that one. So again, SOHCAHTOA would be a possible way to do this. You'd have to find an angle first, and then use that angle to find your side, but you could do it that way. That would not be wrong, and I would not count it as incorrect. It's just going to take you longer to do that. But Pythagorean theorem we can use to find a missing side on a right triangle as long as we know the other two sides. What has to go in for C? 22. The hypotenuse always has to go in for C. It's always going to be my longest side. So I have 22, and that gets squared. And then what do we put in for A and for B? Yep, X for A and 12 for B, or 12 for A and X for B. We need to put the X and the 12 in, and it does not matter which one is A and which one is B. The only one that matters is C. All right, so I have X squared plus, what is 12 squared? 144 equals, and now we need 22 squared, 484. Then we subtract 144 from both sides. X squared is 340. And then how do I get rid of the squared? Square root it. And if you do it to one side, got to do it to the other side. So we're going to square root both sides. Squared and square root cancel. Did it say anything about rounding my answer? Yes. So that means I can put this into decimal form. I don't need the reduced radical form. Thank you so much. So I can pop this into my calculator. I don't have to do like the breaking it down on the other side. You guys remember when we've done the breaking things down? Yeah, if it says anything about rounding in the problem, then you don't have to do that part. What is the square root of 340? 18 point, and then I didn't hear the decimal part. 439. Should we put units with that? Centimeters. Beautiful. Right, so 18.439 centimeters. We still need to find the perimeter, though. You guys told me back on number 5, how do we find the perimeter? Add all the sides. So we're going to add all of our sides together. We only have 3 sides since this is a triangle. One of the sides we just found is 18.439. If you rounded that to 18.44, I would be fine with that. Plus, and then we had a side that was 12. Plus, and then our hypotenuse was 22. So we add all of those pieces together, and we get what? 52.439 centimeters. Very nice. So Pythagorean theorem to find your missing side. Again, we can only do Pythagorean theorem if we know 2 of the sides in the right triangle. If you don't know 2 of the sides, then you have to use SOHCAHTOA. There's no other choice. But if you're using SOHCAHTOA, you should know one of the angles. Or you are finding an angle. SOHCAHTOA, you either find an angle or you have an angle. But again, you could do this one with more steps. You could use the 12 and 22. You could find one of the angles. You'd have to circle it and label it so you know which one you're finding. But you could do inverse function, so either inverse sine, inverse cosine, inverse tangent to find a missing angle, and then use that to find your side, and then from there find your perimeter. What else would you guys like to look at? Number 6? Absolutely, we can do number 6. So first thing I notice about number 6, it says using special right triangle rules. we have 3 special right triangle rules, but we only had 2 types of special right triangles. We had a 30, 60, 90 triangle, and we had 2 formulas for that. Hypotenuse equals 2 times the short leg, and the long leg equals the short leg times radical 3. So that's for a 30, 60, 90. Then we also had a 45, 45, 90 triangle. We only had 1 formula for that. Hypotenuse equals leg times radical 2. I will give you all 3 of those formulas on the test. I will not have them labeled as far as which one goes to which type of triangle. You have to know which one goes to which type of triangle, but I will give you the formulas, so hopefully you don't get confused on those pieces. On the 45, 45, 90, we don't have a short leg and a long leg because the 2 legs are the same size. That's why it's just L instead of SL or LL. All right, top 2, top left and top right. I see that we have a 60-degree angle on both of these. And I see that both of them have a 90-degree angle. The 3 angles in a triangle have to add up to how much? Has to add up to 180. What's 180 minus 90? 90. So these 2 angles have to add up to 90. Well, 60 plus what equals 90? 30. So this angle up here would have to be 30. If I see a triangle and it's a right triangle and one of the angles is 60, the other one has to be 30. If one of the angles is 30, the other one has to be 60. So these are 30, 60, 90 triangles. So that means 2 formulas. Hypotenuse equals 2 times the short leg, and long leg equals short leg times radical 3. Let's label up our triangle in the upper left corner. What is the hypotenuse for this triangle? M. Opposite the right angle is our hypotenuse. So we have short leg and long leg. The short leg is always found in between the 2 biggest angles. So is the short leg N or 36? N. In between the 2 biggest angles, the 60 and the 90, is my short leg. And so that means that 36 has to be the long leg. Can we use the hypotenuse formula first? No, we don't know how big the hypotenuse is. That's just a variable, M. And we don't know how big the short leg is. That's also a variable, N. So we're going to have to use our long leg formula. In the place of LL, we're going to put 36 in. So 36 equals, the short leg is which side? N times radical 3. To get N by itself, we're going to divide both sides by radical 3. So it cancels out over on the right. Over on the left, I have to be careful. Am I allowed to leave a radical in the denominator like that? No, so we've got to multiply top and bottom by the radical that we don't want down on the bottom. So radical 3 over radical 3. So in my numerator, that would give me 36 radical 3. In my denominator, I have radical 3 times itself, or radical 3 squared. What happens when you square something that's being square rooted? Cancels out. So what do I have actually down in my denominator then? 3. 36 radical 3 over 3 equals N. I got rid of the radical in the denominator, so that's good. The last thing I have to do is see if I can reduce this fraction. So the 2 pieces that are not underneath the radical. Does 3 go into 36? How many times? 12. So 12 radical 3 is equal to n. All right. We are ready for our other formula now. Hypotenuse equals 2 times the short leg. The hypotenuse is represented by which variable? M. So M equals 2 times, what was the short leg? 12 radical 3. These two numbers right here, the 2 and the 12, are being multiplied together, and neither one of them is underneath a radical. So we can just multiply those two pieces together. What is 2 times 12? 24. So M is 24 radical 3. So far, so good? All right. Let's come over to the other one. Hypotenuse equals 2 times the short leg, and long leg equals short leg times radical 3. Let's label up our triangle. What is the hypotenuse on this triangle? 18 radical 3, because that's opposite my right angle. So here's the hypotenuse. What's the short leg? X. And so that means Y is the long leg. Which of these two formulas do I have to use first? The hypotenuse formula or the long leg formula? Hypotenuse. In the place of H, we're going to replace that with 18 radical 3. So 18 radical 3 equals 2 times my short leg, which you said we're calling X. To get X all by itself, we need to divide both sides by 2 so that I can make the 2 cancel out on the right. And I need to know whether or not 2 can go into 18. How many times can 2 go into 18? 9. So 9 radical 3 equals X. Yes? All right. Now we're ready to use our long leg formula. You're welcome. So in the place of LL, we're going to put Y. What should go in for SL? 9 radical 3. And then we bring down our times radical 3, this piece right here. In between the 9 and the radical 3, there is multiplication. So these two pieces that are both underneath the radicals are being multiplied together. So I would have Y equals 9 times, and then this would be radical 3 times itself, or radical 3 squared. What is the square root of radical 3? Just 3. The squared and the square root cancel each other out, so I'm just left with 3. So Y equals 9 times 3. What is 9 times 3? 27. So Y equals 27. So far, so good? All right, let's look down at the bottom two now. I see a right angle right down here, and I see a 45-degree angle. How big does this other angle have to be then? Has to be 45. These two angles are the same size, which means these two sides are the same size. So how big is N? 8. For a 45, 45, 90, hypotenuse is equal to leg times radical 2. The hypotenuse is being called M. So M is equal to 8 times radical 2. So M is 8 radical 2. Similar kind of triangle over here on the very last one. We have a 90-degree angle here and a 45-degree angle here, which means this other angle is also 45 degrees. The 4 is my hypotenuse because it is opposite that right angle, just like M was over here. And so that means that U and V are my legs, and they are congruent. So hypotenuse equals leg times radical 2. What can I substitute into that formula? V. V can go in for which piece? The leg. Okay, so we're going to put V in here times radical 2. Do we have anything that we can put in for H? 4. Perfect. Now to get V all alone, we're going to divide both sides by radical 2. Could we have put U in instead of V for the leg? Yes, they're the same size, so it doesn't matter whether I substitute in U or V. Can't have a radical in my denominator like this, so I have to multiply top and bottom by radical 2 over radical 2. So I would have 4 radical 2 over radical 2 squared equals V. What happens in my denominator? Cancels. Squared and square root cancel. So I have 4 radical 2 over 2 equals V. And then I have to reduce this fraction down. Can 2 go into 4? How many times? Twice. So 2 radical 2 equals V. So how big is U? 2 radical 2. Very nicely done. Very nicely done. Like I said, I'll give you the formulas for the 30, 60, 90 and for the 45, 45, 90, but you need to match up which ones go with which. It'll be printed at the very top of your test on Wednesday, so you can even go in and like circle the ones that go to a 30, 60, 90 and write that on there. And then do the same thing for the 45, 45, 90, and then go about your business on the test. And that way you don't have to go back and look at and figure it out while you're in the midst of it. Thank you. Yes. Yes, you may. What else would you guys like to see from the review? Yes. Number 7, absolutely. Number 7 is a really good one for us to go over. What kind of triangle are we looking at here? Equilateral. And what do we know about an equilateral triangle? Yes, all 3 sides are congruent. It says it has a perimeter of 54 feet. How do you find perimeter again? Add all the sides together. So when I add all the sides together and all the sides are the same, I get 54. So how do I figure out the size of just one side? Divide by 3. So 54 feet divided by 3 comes out to be what? 18. 18 feet. So PR right here is 18 feet. PQ over here is also 18 feet. And across the bottom, QR is 18 feet. Equilateral triangles don't just have 3 equal sides. They also have what? 3 equal angles, 3 congruent angles. The 3 angles in a triangle have to add up to how much? 180. If they're all 3 the same size, how do I figure out the size of one of them? Divide by 3. So I'm going to do 180 divided by 3, and that gives us what? 60. So angle Q is 60 degrees. Angle R is 60 degrees. What's happening to angle P up at the top? It's what? 30 on both sides. Yes, it's being split in half here. So this is the same size as this, and they're both 30. So that together they make that 60-degree angle up at the top. So what kind of triangle have we made by looking at just half of this? We have a 30, 60, 90 triangle right here, because there's a right angle here, just like there is on the other side. So we have a 30, 60, 90 triangle. We had two formulas for that. Hypotenuse is equal to 2 times the short leg, and long leg is equal to short leg times radical 3. If I'm looking just at the yellow triangle, what would the hypotenuse be? 18. Here's the hypotenuse. So in the place of h, I can replace that with 18. So 18 equals 2 times, what would the short leg of that yellow triangle be? Just which side of the triangle? QS, yes. QS would be the short leg. So I'm going to put in QS here. Then we divide both sides by 2 to get QS by itself. And some people were already answering this for me. How big is that short leg? 9. 9 is equal to QS. We're going to stick units on that, so that would be 9 feet. All right. Then we get to our other formula. Long leg equals short leg times radical 3. What is the name of the long leg on the yellow triangle? PS. So PS equals the short leg, and we said short leg was how big? 9 times radical 3. So PS is 9 radical 3. We're going to stick units with that, so 9 radical 3 feet. We are leaving it in this form because it says answers must be in radical form. So don't put 9 radical 3 into your calculator. Yes? Uh-huh. Is it okay if we don't show up for it? Yep. I just did 9. Yep. I would be fine without seeing work for that. Yes. If you looked at the equilateral triangle and you're like, I know that line going straight down the center of the triangle is going to hit at the midpoint, that S is a midpoint, then yeah, you could just take 18, divide it by 2 in your head, and write down 9. Absolutely fine. In fact, for either of these, I don't have to see work. Answers would be enough on these. What else would you guys like to see? We have time for 2 or 3 more problems, depending on how long they are. Yes. Number 8? Number 9, absolutely. Let's go look at number 9. This is a really good one. So the first thing we're going to do is find the sine, cosine, and tangent for angle J. You guys had a problem that was almost identical to this on the skills check that you took on Friday. So first thing I'm going to do is I'm going to come over here to angle J, and I'm going to circle that. This is where we're standing. And I'm going to label all of my sides based on standing there. The hypotenuse is opposite the right angle, so 34 is my hypotenuse. Opposite angle J is 16, so that's my opposite side. And so 30 would have to be which side? Adjacent. Sine, so S equals O over H. The opposite side is 16. The hypotenuse is 34. So 16 over 34. And we are leaving this just as a fraction. You don't need to do anything else to it. We're not finding the size of the angle. We're not even reducing the fraction down. We're just writing down what that ratio would be. And then cosine is equal to adjacent over hypotenuse. The adjacent side is 30. The hypotenuse is 34, so 30 over 34 for cosine of j. And then TOA, tangent equals opposite over adjacent. The opposite side is 16. The adjacent side is 30, so tangent of j equals 16 over 30. To do sine, cosine, and tangent of angle K, I need to change where I'm standing. So I'm going to redraw this triangle. You guys don't have to if you don't want to. But I'm going to redraw my triangle here. I would have my right angle right here. Here's L. This is 30. Here's J. This is 34. K. And 16. So now we're standing down here at K. And we label our sides based on where we've moved to. Hypotenuse didn't change. Hypotenuse is still 34. But now, opposite the angle that I'm standing at is 30. And the adjacent side would be 16. So the hypotenuse stayed in the same spot, but the opposite and adjacent switched. So for sine, opposite over hypotenuse, my opposite side is 30. My hypotenuse is still 34. So 30 over 34. Notice that's exactly the same as the cosine of the other angle. Cosine of one angle is equal to sine of the other angle. Cosine adjacent over hypotenuse, my adjacent side is 16. Hypotenuse is still 34. Notice that's the same as the sine of j. Cosine of k is the same as the sine of j. And then tangent, TOA, opposite over adjacent, we would have 30, my opposite side, over 16, my adjacent side. When I compare the tangents, they are not the same, but they are reciprocals. It's the same two numbers, but they're flipped over on the fraction from each other. What else would you guys like to look at? What else would you like to see? Which one? Number 10, absolutely. Let's go look at number 10. Find the missing side and round to the nearest hundredths. So we're going to circle the angle that we're standing at. We always have to stand inside the triangle. If we have an angle that is outside of the triangle, you're going to have to use that to find an inside angle. So always has to be an angle inside our triangle. Then we label our sides. We have hypotenuse, which would be y right here because it's opposite the right angle. Then we have our opposite side, opposite where I'm standing, which would be x on this triangle. And then we have 33, which is our adjacent side. All right, SOHCAHTOA, S equals O over H, C equals A over H, T equals O over A, SOHCAHTOA. Let's find x first. X is my opposite side, right? What's the only side that we actually have a number for? Adjacent. Which of those functions would I use if I have opposite and adjacent that I want? Tangent. So we're going to use this to find x. So tangent of 18 degrees equals my opposite side, which is x, over my adjacent side, which is 33. X is part of a fraction, so we're going to use multiplication to get it out of the fraction. And we always multiply by the denominator, which is 33 on this fraction. So we multiply top and or left and right by 33. So into my calculator, I put 33 times the tangent of 18 degrees. What is 33 times the tangent of 18? Yep, 10.722 for x. All right, now we have to do SOHCAHTOA all over again to find y. Y is the hypotenuse, and we have a number for the adjacent side. So hypotenuse and adjacent would be which one? Sine, cosine, or tangent? Cosine. Adjacent and hypotenuse means we would choose cosine. All right, so cosine of 18 degrees equals the adjacent, 33, over the hypotenuse, y. What we're looking for, y, is part of a fraction. So once again, we're going to multiply, and we always multiply by the denominator. So we're going to multiply both sides by y. So we have y times the cosine of 18 degrees equals 33. And then we have to get rid of this multiplication right here. So we're going to divide both sides by the cosine of 18 degrees. Make sure you hit division on the calculator and not multiplication. It'll give you a similar but wrong answer. What is 33 divided by the cosine of 18? $34.698. All right. Very similar process for the bottom problem. We're going to stand here at this 57-degree angle. We're going to label our sides based on where we're standing. The hypotenuse is y. The side that is opposite where we are standing is 37. And so x is our adjacent side. SOHCAHTOA comes out. If we are looking for x, and we know the opposite side, which function should we choose? Tangent. Adjacent and opposite means choose tangent. So we have tangent of 57 degrees equals the opposite side, 37, over the adjacent side, x. Multiply both sides by the denominator, so we multiply both sides by x. Cancels my denominator over here on the right. So I have x times the tangent of 57 degrees equals 37. Need to break up this multiplication right here, so we're going to go with division to get rid of the multiplication. Tangent of 57 on both sides in my denominator. Cancels out over on the left. We get that x is how big? 24.028 is correct. And then the very last piece here, we need to find y. So we break out SOHCAHTOA. Y is my hypotenuse. I know the opposite side, so which function do I have to choose if I'm going to use opposite and hypotenuse? Sine. This is to find y. So sine of 57 degrees equals the opposite side, 37, over the hypotenuse, which is y, multiply by the denominator, so multiply both sides by y, so we have y times the sine of 57 degrees equals 37. Divide both sides by the sine of 57 degrees. And what is 37 divided by the sine of 57? 44.117. Absolutely correct. There will be a video posted for every single class today. The answer key is already posted in Canvas. I will not be here tomorrow. You will have a one-page review that the substitute will give you that you have to turn in tomorrow. But this test review is not due until Wednesday. Have a great rest of your day, guys. I'll see you on Wednesday for your test.